In this video, I'm going to work my way through 30 different questions on algebra to try and do all of the topic of algebra all in one go. So first of all, you need to know what these different fancy words mean: expression, equation, formula and identity. So first of all, an expression is just whenever you express something using letters. So something like 2a plus 3b would be an expression. As soon as you put it equals to something, then you have an equation. And a formula is a bit like an equation, but it's actually about something. Like the formula for the area of a circle would be pi times radius squared. So area equals, so it's got an equal sign in it as well, but it's normally actually about something. Whereas equation can just be random with random letters in it. And an identity is whenever you have a triple equal sign, and that actually just means the same as equivalent to or equal to. So write down which is which. So 3x plus 8 is equal to 5. That would be an equation because it's got an equal to in it, and you would actually be able to solve that and get an answer for x. 3 bracket x plus 5, and then you've got the wee triple equal sign, so that means that it's an identity. And all that's meant by that is just that the left side is equivalent to the right side. If you expand that bracket out, you would get 3x plus 15, which is the same as what we've got on the right side. So they are equivalent to each other. Then P equals 2L plus 2W. That's a formula for the perimeter of a rectangle. 2 lengths plus 2 widths will get you the perimeter of a rectangle. So that one is a formula, because it's got an equal to in it, but it's actually about something. Although you'd get the mark in the exam for that one if you said that it was an equation, because it's an equation as well as a formula. Then the last one, 15x minus 7y, that is just an expression. It's got no equals to sign or equivalent to sign in it, so that is just an expression. The next section then is all about simplifying. So you'll just see the word simplify over and over and over, and that's all the different ways that you can simplify something. So simplify just means make it look a wee bit nicer, make it look a bit easier looking. So you would just simplify this by putting the x's with the x's and the y's with the y's. So whenever you're adding and subtracting, you can only put like with like, you can only put the same letters together. So this 5x goes with the 2x, and it tells you what to do with the 2x just in front of it. So that plus sign belongs with the 2x. So you do 5x add 2x totals up to 7x. And then whenever you come to the y's, you've got minus 3y. So that negative sign there belongs with the 3y. And then add on or go up 5y. So if you're down at negative 3 and you go up 5, you end up with positive 2. So you put a plus in and then your 2y. What you can't do at this stage now is actually add these two together. 7x plus 2y doesn't get you 9xy or anything like that. You can't add your x's and y's together. You just leave the x's with the x's and the y's with the y's. You can multiply any combination of letters together, but whenever you're adding and subtracting, they have to be the same letter. Part B then, simplify t to the power of 4 multiplied by t to the power of 8. Whenever you're multiplying and you've got the same base letter, so you've got t's at the bottom here, the quick way to do it is just for you to add the powers, because t to the power of 4 means 1, 2, 3, 4 t's multiplied together, and then t to the power of 8 means another 1, 2, 3, 4, 5, 6, 7, 8, all multiplied together. So whenever you're multiplying all of those t's together, that would give you t to the power of 8, 9, 10, 11, 12. The next one then, simplify w to the power of 15 divided by w to the power of 3. The quick way to do that whenever the base letter is the same and you're dividing is just to subtract the powers, because w to the power of 15 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you're dividing that by w 3 times, which means 3 of them go off the end of that, and you're left with 12 of them multiplied together, so w to the power of 12. Don't fall into the trap of multiplying the 4 by the 8 or dividing the 15 by the 3. When you're multiplying, you add the powers, dividing, you subtract the powers. Question 3 then, some more simplifying. 3c multiplied by 4c. So we are multiplying 4 by 3, which would get you 12, and then c multiplied by c gets you c squared. Whenever you multiply the same letter together, the power goes up. So c times c gets you c squared. If it was just c plus c, that would get you 2c, but whenever you multiply them, you get a c squared. Part B then, simplify this. So you would multiply the two number bits together, so multiply 6 by 5 would get you 30. And then D times E, when it's different letters that you're multiplying together, the way you write them down in algebra is just by writing them side by side. So C times C gets you C squared, but D times E just gets you DE. Then simplify this, we've got different letters again here. So adding and subtracting, the A's only go with the A's, and this A on its own is a 1A, and it's a take away 1A. So 7A take away 1A would get you 6A. And then you've got 8B take away 9B. So if you've got 8 and you take 9 off it, that's going to bring you down to negative 1B or just negative B. It doesn't matter whether you put a 1 there or not, you'll not be marked right or wrong whether you've got it. Okay, so just remember with your algebra, if you are adding y's together, you get 2y. Well, it's gone out of focus there. If you're adding y's together, y plus y will get you 2y, and if you're multiplying y's together, y times y will get you y squared. So try not to get those two mixed up. We didn't come across any cubes there. If you have something like x plus x plus x, that just gets you 3x, the number goes at the front. But if you multiply them, x times x times x gets you x cubed. So again, try not to get those two mixed up. The next bit of algebra then that I want to look at is expanding or multiplying out brackets. So in the exam it'll either be worded as multiply out or they'll just use the word expand. So expand means make it bigger, and the way you make it bigger is by multiplying everything inside the bracket by what's in front. So for this one you would take the x and multiply it by 3, and then take the 2 and multiply it by 3. So 3 times x gets you 3x, 3 times 2 gets you 6. And then you just copy the adding sign down. You can't actually add those together because one of them's got a letter and the other one doesn't. Then y bracket y minus 5. To expand that, you multiply everything inside by the y in front. So y times y gets you y squared, and then y times 5 gets you minus 5y. Question 5 then, we've got some questions with 2 brackets in them. So you treat it like 2 separate questions really. Do the first bracket separate to the second bracket. So the first one has to be multiplied by 3. So 3 times x gets you 3x, 3 times 2 gets you 6. Then over here 4 times x gets you 4x, and 4 times negative 1 gets you negative 4. And this question, it doesn't just say expand, it says simplify as well. Because you're able to simplify this, you're able to put the 3x, add the 4x together to get you 7x. And you're able to do the plus 6, take away 4. So if you've got 6 and you take away 4, you've got 2 left. So that's a plus 2 at the end rather than a negative 2. Part B, expand and simplify again. So multiply everything inside this bracket by 6. So 6 times 3y gets you 18y. Then 6 times 2 gets you 12. And the second bracket, 3 times 4y gets you 12y. And copy down the plus. And then 3 times negative 5 will get you negative 15. And then simplify it. You can do 18y, add 12y, get you 30y. And then 12, take away 15. You're taking away more than what you've got, so you're going to go into your minuses. You'll end up at minus 3. So it's a take away 3 at the end of that one. Part C then, multiply everything inside the bracket by 7. So you would have 7p plus 21. And then the negative in front of this bracket will change the sign in front of it. So it's negative 2 times p will get you negative 2p. And then the negative 2 times the negative 5, that will turn it into a positive 10. So whenever you've got a minus in front of the bracket, the sign in front of the bracket will change. And then you can simplify that. 7p take away 2p will get you 5p. And then 21 plus 10 will get you 31. So 5p plus 31 for that one. So remember, the negative in front of the bracket will change the sign inside. Then the next word I want to look at is factorise. That's the reverse of expanding brackets. So it's a bit like you making up the question and putting the brackets back in. So some bracket has been multiplied out to get you y squared plus 8y. The reason it's called factorise is because out in front of the brackets are your factors. So that's what you can divide this term by and this term. So both of these have a y in them, so you put a y out in front. And then I just work in reverse and think y times what would get me y squared. Well, y squared comes from y times y, so it would have to be a y in there. And then y times what will get me 8y. So the difference between this term and this term is the 8 in front of it. So it must be an 8 that I put in the brackets there. The handy thing with factorise is that you can always check your answer and check that if you actually multiply that out, will you get back to the question? So if you were given this and the question was just expand, you would multiply y with y to get you y squared and y with 8 to get you 8y. So yes, it does multiply back out again. You don't actually have to multiply it back out. You'll just get back to the question, but it's just a way for you to check it. Part B then, it says factorise fully, and the reason it says factorise fully is because you're able to take out more than just one thing. So 10 and 8 are both in your 2 times table, so you're able to take out a 2. But also the c squared and the cd both have a c in common, so you can put the c out in front. So whenever it says factorise fully, that's a good indication to you that you have more than just one out in front. You don't just have a letter or just have a number, you have both. And then work backwards, so 2c times what will get you 10c squared? Well, you would need the 2 times the 5 to get the 10, and the c times the c to get the c squared. And then over here, 2 times what will get you 8, it would be 4, and 2 times, or the c times d would get you cd. Whatever the sign is here, that's the sign that you will have in your answer. So if it's a plus in the question, it will be a plus in your answer. Then part C, factorise, and it's all just letters here, which means obviously out in front of your bracket, it's just going to be whatever letter appears here and here. So in that question, it would be an A. And then A times B gets you AB, and A times C gets you AC. And then just copy down whatever the sign is. If that was negative, you'd copy down a negative sign. So try to remember the word factorise. It just means put brackets back in, and it's the reverse of expanding brackets. So you should be able to multiply your answer back out if you wanted to check and see that you get back to the question again. Okay, the next word that I want to look at then is substitution. So this is whenever you want to get rid of the letter and put a number in instead of it. So a bit like if you were using a sub on a football pitch, or there was a substitute teacher in or something like that, where the teacher or the football player isn't there anymore and there's something else in place of them. So if c is equal to 5, work out the value of 3c plus 2. So they're telling you there the value of c, each c is worth 5, and 3c means 3 c's or 3 times c. So 3c, you do 3 times 5 is 15, and then plus on the 2 would get you 17. You don't put the c back in. The whole point of substitution is that the letter goes and the number goes in place of it. And remember, 3c means 3 times c. You don't just put the 5 in and make it 3 5 like 35. You do 3 times 5 to get the 15. Question 8, what is the value of 3b plus a squared whenever a is equal to 4 and b is equal to 10? So 3b would be 3 times b, so you do 3 times 10 is 30, because b is equal to 10. A squared means a times a, and a is equal to 4. So that would be 4 times 4, which is 16. And then you're wanting to add those together and you would get 46. So for questions like this, you really need to know what each of these terms mean, like that's 3 times b and that's a times a, to be able to substitute the numbers in properly. Number 9, work out the value of 8x plus 4y whenever x is equal to 2 and y is equal to minus 3. So 8x means 8 times x, so that would be 8 times 2, which is 16. 4y means 4 times y, but y is negative 3. So 4 times negative 3 would get you negative 12. And then you're wanting to add those together. But whenever you add them together, you end up with 2 signs here right beside each other. One's positive, one's negative. So the negative is the one that wins. So you keep the negative and lose the positive. So you do 16, take away 12, leaves you with 4. And again, you don't put any sort of x's and y's back in again. Once they're gone, they're gone. You put the numbers in place of them. Number 10, when a is equal to 2 and b is equal to 3, the value of a, b, c is 30. Work out the value of c. So a, b, c means a times b times c, and you're getting the answer 30. So a is 2 and b is 3. So 2 times 3 times something will get you 30. And that will tell you what c is. So you do 2 times 3 is 6, and then 6 times 5 would get you 30. So the value of c must be 5, would be your answer for that one. Number 11, if 2x plus y equals 10, work out 2 possible pairs of values for x and y. So they're wanting you to make up your own numbers here for x and y, which means that there'll be loads of different combinations that you could use. So I'm going to start off with putting x equal to 1. So if I put a 1 in there, 2x would become 2 times 1, which is equal to 2. And then plus something will get me 10. So plus 8 would get me 10. So that means that I'm making y equal to 1 and x equal to 8. So that would be one possible pair that would work. If x is equal to 1, y would have to be equal to 8. So then find another pair, maybe put x equal to 2. So if I put x equal to 2, 2 times x would be 2 times 2, which would get me 4. And then plus something has to get me 10. So plus 6 would get me 10. So that means that y would have to be equal to 6. There are more answers than that. You could put x equal to 3 and do 2 3s or 6 plus 4 would get you 10. So have 3 and 4. Or you could put 4 in there, 2 4s are 8, plus 2 would get you 10, so 4 and 2. Or you could even put a 5 in there and have 5 and 0, 2 5s are nothing, or sorry, 2 5s are 10, plus 0 would get you 10. So there's loads of different answers there. I was just asked for 2 possible pairs, so there's 2 possible pairs. Okay, that's substitution then. The next bit of algebra that I want to look at is solving equations. So all of these, you have an equation, so you have an equal to sign, and you want to solve it and work out what y could be equal to. Some of them you're able to do in your head, some of them are not as straightforward as that. So 12a, solve 5y equals 50. That just means 5 times what is equal to 50. So you should be able to do that in your head. 5 tens would get you 50, so y is equal to 10. The method that I like to use is 5y means 5 times y. And for you to get y on its own and solve it, you need to get rid of the times by 5. So bring it to the far side, and whenever you change sides, you change signs. So a times by 5 turns into a divide by 5. And then 50 divided by 5 gets you 10. So yes, you might be able to do that one in your head, but this method comes in very handy whenever you've got negative numbers or awkward fractions or decimals or something like that. So to get the y on its own, move the times by 5 over there and divide by 5. Part B, you would definitely need to show some working out for. You'll lose marks if you don't. So 4z, take away 5 is equal to 11. So we want to solve it and work out what z is. Leave the 4 with the z for a wee minute. And move this take away 5 that's on its own. So move it to the far side, and a take away 5 becomes an add 5. So we're left with 4z on the first side, and 11 plus 5 equals 16 on the second side. I would try to keep your equals all in line here. You can even draw a line in if you want. So as soon as you go past the line, pluses and minuses turn round. So 4z equals 16. You should be able to solve and work out what z is on its own, or on your own. So 4 times 4 would get you 16, so z is equal to 4. Or 4z means 4 times z. Bring the times by 4 over there and divide by 4. Z is equal to 4. Part C is solving again. But this time we've got a bracket, so what you need to do first here is just get rid of the bracket. So multiply everything inside the bracket by what's in front. So 3 times w gets you 3w, 3 times 2 gets you 6, and then you copy down the takeaway sign, and that is equal to 9. Once you've got rid of the bracket, then you can go on and solve it by moving everything away from the w. So leave the 3 with the w for a wee minute. Get rid of the takeaway 6 by bringing it to the far side and adding 6 on. So you're left with 3w still on the first side, and 9 plus 6 gets you 15. Then this bit you can do in your head. 3 times what gets you 15? 3 5s get you 15. Or bring the times by 3 over there and divide by 3. So 15 divided by 3 gets you 5. And again, if you wanted to, you could put that line down there just to make sure that your equals are all in line with each other. It might make it easier once you see them moving past the line then. You know that your minuses need to turn into plus and your times need to turn into divide. Then part D, solve, and this means x divided by 3 equals 4. So you want to know what divided by 3 equals 4. You could work it out in your head if you know that 12 divided by 3 gets you 4. Or if you want to show a method, you would bring your divide by 3 over there, and dividing turns into times. So multiplying and dividing swap around, adding and subtracting swap around in solving. So a divide by 3 turns into a times by 3, so x equals, and then 4 times 3 gets you 12. Shorter ones like that, it's perfectly fine just for you to do it in your head, but I'm just going to stick with the same method of always showing my working out. Number 13, solve, and this time you've got letters on both sides of the equal. You've got 2 sets of y. So for you to solve these, you need to first of all get all of the y's together on the first side, and then get all of the individual numbers together on the second side. So we're wanting to get all of the letters over here. So you need to move that y over here to be with the 3y. Over here it didn't have anything in front of the y, so that means that it's positive, and it's also a 1y. So a plus 1y, whenever you move it over to the other side, that will turn into a take away 1y. So that's you getting your y's together. And then you need to get that take away 11 over to the far side to be here with the 4. And a take away 11 turns into a plus 11. After that then you need to work out what you've got on each side. So 3y take away 1y gets you 2y. And a 4 plus 11 would get you 15. And then you should be able to solve that wee bit at the end. 2 times what gets you 15? If you don't know, bring the times by 2 over there and divide by 2. And 15 divided by 2 gets you 7.5 or 7.5. So the key to this one, where you've got letters on both sides, is to get all of the letters on the first side and all of the numbers on the second side. So circle the letter on this side, bring it over there and do the opposite. So a plus 1 turned into a take 1. Take the minus 11 over to the far side and add it on. And then solve the way you would normally solve. Part B is solving again with letters on both sides again, but this time one side has a bracket in it. So the first thing you would need to do is get rid of the bracket. So multiply everything inside by 5. So 5 times m gets you 5m, and then 5 times 2 would get you 10. This side doesn't have a bracket, so you don't go multiplying it by 5. The only thing that you multiply by 5 is what's in this bracket. So the 8 minus 2m stays as it is. And then follow the same method as the last question, where you get all the letters onto the first side, all of the numbers onto the second side. So this time it's a negative 2m that's coming over here to be with a 5m, so it turns into an add 2m. And the plus 10 is going over to the other side to be with the 8. But the plus 10 turns into a take away 10. So you've got 5m plus 2m gets you 7m, and 8 take away 10 gets you minus 2. And then what you're left with here, it's not very nice, but this does happen sometimes, even on the non-calculator paper, so you need to know how to finish off solving these ones. So that's where my method that I was using back up here comes in quite handy. You bring that times by 7 over there and divide by 7, and you can just leave your answer as minus 2 divided by 7, minus 2/7, and it's fine for you to leave it like that. If you've got a calculator, yes, you could type it in and get your answer, but it won't make any difference. They'll accept just the minus 2 over 7, unless they specifically ask for you to give your answer as a decimal or something. It's fine for you to leave it as a fraction. Okay, I've got a few more solving questions, but they're a wee bit trickier. So number 14, the diagram shows a triangle and the perimeter of the triangle is 27. So this is bringing in perimeter as well as algebra. So the perimeter is the total distance around the outside of the triangle, and they're telling you that that's equal to 27. Set up and solve an equation to find the value of y. So for you to set up this equation, you would have to take into consideration that perimeter means the total around the outside, and that it's equal to 27. So you would total up around the outside first of all. So go round and total up all of the y's. So you have 2y plus another y is 3y plus another y is 4y. So the first bit of your equation would be 4y. And then go to the numbers that are on their own. You have 4 here and then take away 1. So that would leave you with 3. So that's an expression that you've set up for the perimeter. It turns into an equation as soon as you put it equal to the 27 that they told you it was equal to. So 4y plus 3 is an expression for the perimeter, and then 27 is the number version of the perimeter, what it's actually equal to. So that's it set up, and now you can solve it. So move everything away from the y, move the plus 3 over and take it off. So you've got 4y equals 24. And then 4 times what gets you 24, or else bring the times by 4 over and divide by 4. So y equals 6. So you could go round then and check by putting 6 in there, and 6 in there, and 6 in there, and check that your perimeter does actually total back up to 27, just if you're in the exam and you want to check that you're right. Number 15. The straight line AB has angles 2x, x plus 10 and x minus 30. Set up and solve an equation to work out the value of x. So the equation that you're going to set up here, it's to do with angles, and they make a straight line, which means that they're going to add up to 180. So add them up using algebra. So 2x plus another x is 4x. And then you've got 10 take away 30. That will get you negative 20, or take away 20, equals 180. So last time they told you the perimeter was equal to 27. This time they didn't tell you what it was equal to, because they would expect you to know that a straight line totals up to 180 degrees. So then solve that by bringing your negative 20 over there and adding it on. So you've got 4x equals 200. And then you don't want to know what 4x is, you want x. So you need to bring your times by 4 over there and divide by 4. So x is equal to 50. Again, if you wanted to check your answer, you could put 50 in there, 50 in there, 50 in there, and then check that it actually totals back up to 180, just if you weren't sure. So that page was just really to show that algebra, it's not just something that is completely separate from all the other topics. They can mix it up with things like perimeter or angles. They can put it in with anything really. So the next bit that I want to look at is called trial and improvement. It is actually part of solving equations, but it's just where you can't follow the same method as what I was just showing you there in the last couple of pages. So it's called trial and improvement because you just try a number, see if it works. If it doesn't work, improve your estimate or improve your guess, try a slightly different number and try to get as close as possible to the answer. So we're wanting to use trial and improvement to find the solution to this equation here. So we're looking at x cubed plus 2x equals 56. So we're trying to work out what cubed plus 2 times what will equal 56. And obviously whatever we put in for the x over here, that's what you put in for the x over here. So they've already tried 3. So they've done 3 cubed plus 2 times 3 and got 33 for the answer. We're looking 56. So the comment space that they've given here, you would just write that it's too low. So we are trying to get this as close to 56 as possible. When it says give your answer to 1 decimal place, they mean your final answer here, not every wee bit of your working out here. So 3 is getting you an answer that's too small. So you would try the number 4 then. So do 4 cubed plus 2 times 4. So everywhere there's an x, I'm putting in a 4 there and a 4 there. So go to the calculator and do 4 cubed would be 4 with that wee button. 4 cubed plus 2 times 4 gets you 72. And 72 is too big. But that's sort of what I was expecting anyway. I'm just going to try to get this a wee bit brighter. See if that helps with the calculator slightly. Whether that makes it better or worse. A wee bit better, possibly. Right. So 3 was too small, 4 was too big, so the next number then that you would try would be 3.5. So try halfway in between those. So do 3.5 cubed plus 2 times 3.5 and see what you get for that. See how close you get to 56. So 3.5 cubed plus 2 times 3.5 gets you 49.875. So 49.875. Remember, we're looking for 56, so that's slightly too low again. So I'm going to try and put it up a wee bit higher. So just go up another decimal place. So go up to 3.6. So do 3.6 cubed plus 2 times 3.6. So go along and replace x with 3.6 everywhere. So 3.6 cubed plus 2 times 3.6. This time that gets me 53.856. That is still slightly too low, so I need to go up again. So try 3.7. So 3.7 cubed plus 2 times 3.7. So 3.7 cubed plus 2 times 3.7 gets me 58.053, and I'm looking for 56, so that one is slightly too big. Once you get to this point where you've tried your couple of whole numbers, you've gone halfway in between them, you've realised that you need to go up a wee bit bigger, and you've now got to the stage where you've got 2 numbers that you've tried with 1 decimal place, one's too small and one's too big, you know then that your answer is actually going to be somewhere in between them. But they don't want to know exactly what the answer is, they just want your answer to 1 decimal place. So they want you just to choose either the 3.6 or the 3.7, whichever one gets you an answer that's closer to 56. So looking at these two then, it's quite hard to see actually which one is closer to 56. So that's 2 and a wee bit above, and that one's 2 and a wee bit below. So you could just take them away from 56 to see which one is the closest. But what they expect you to do in the exam to decide for definite is go on and try halfway in between those 2 numbers. Even though you're not actually going to pick this for your answer because you only wanted to 1 decimal place, they would still expect you to try it to see what happens. So 3.65 cubed plus 2 times 3.65. So 3.65 cubed plus 2 times 3.65 gets you 55.927 something. So that is just slightly too small. It's just a wee bit below the 56. Or too low, sorry, we're using low and big. So that's just slightly too low. So, because the halfway point here is too low, that is supposed to be the proper mathematical reason as to why you choose the bigger one out of these last 2. So you should be choosing 3.7 for your answer rather than 3.6. because the halfway point is too low, so you choose the bigger one. So choose for your answer x equals 3.7. Make sure whenever you're writing down your answer, you don't make the mistake of writing in that number. They've already told you that the solution to it, or the answer to it, is 56. They're wanting you to find the solution for x. So x is 3.7 will get you the closest to that answer. Normally in the exam, these are worth about 4 marks. You will lose a mark if you don't try that halfway point. And they can also get you to do this on a non-calculator paper by giving you nicer numbers to work with. So watch out for it. It doesn't just have to be on the calculator paper. And sometimes they don't even tell you that it's trial and improvement, so just look for them saying something like, show that it has a solution between 4 and 5 or something like that. Right, the next bit I want to look at are inequalities. So these are a wee bit like equations, except they don't have an equal to. So equations have an equal to. Inequalities have either the less than or more than, a less than or equal to, or more than or equal to. So equations have an equal to, inequality have these arrows here. But whenever you're solving them, you solve them exactly the same way as I was just solving equations. So if you wanted to, you could even turn that into an equals if you really don't like the arrow. But just remember to put the arrow back in at the end. So to solve this then, I would bring the minus 2 over and add it on. So I would have 7x is bigger than 19 plus 2 is 21. And then to get x on its own, bring the 7 over there and divide by 7. So x is bigger than 3. So you can see the only difference there is that you don't end up with an x is equal to 3. You end up with an x is bigger than 3. That's all. Apart from that, it's exactly the same as solving an equation. The same sort of thing for number 18 then. We're wanting to solve this and there's letters on both sides. So follow the same rule as what we did for just normal equations of getting all of the letters onto the first side. So you would move the 4y over here to be with a 6y, but because it's positive here, it's a take away over here. And move the plus 2 over there and take it off the 7. So 6y take away 4y leaves you with 2y. And then this time it's less than rather than equal to. And then 7 take away 2 would leave you with 5. Then you can either do 2 times what gets you 5, or else do 5 divided by 2. So y is less than 5 divided by 2 is 2.5, or 2.5, whatever way you want to leave it, or 5 over 2 would be okay as well. But again, you have a less than sign here rather than an equal to sign. But you solve it exactly the same way. Number 19, we're going to solve this the same way as we solved an equation. So we need to get rid of the bracket. So 4 times x gets you 4x, 4 times 1 gets you 4, and that's less than 7 rather than equal to 7. And then bring the plus 4 over and take it off. So you've got 4x is less than 7 take away 4 will get you 3. And then bring the 4 over, divide by 4, so x is less than, and then either 3/4, or you can turn it into a 0.75, it doesn't matter. If you don't know that 3/4 is 0.75, then you can just leave it as 3 over 4, that's fine. Number 20 then, solve this inequality, do exactly the same as what we were doing before, bring the plus 3 over and take it off, so 2x is bigger than or equal to, 1 take away 3 is minus 2. Then bring the 2 over there and divide by 2. So x is bigger than or equal to negative 2 divided by 2 gets you negative 1. So this is the first wee bit now that we're coming on to that is different to the equations that we've done, where it asks you to write down the inequality shown by the following diagram. So they've put the inequality just along a number line. So they've plotted it at the number 2, and this is all to do with x. So you know that you're going to have x on one side and 2 on the other. All you have to do is decide what way the arrow is going to go in here. So because the arrow in the picture is going down here towards the smaller numbers, it's going like that. That's the way it goes in your answer. And then if the dot here is coloured in, you would make that a less than or equal to sign, put the wee line in underneath. But this dot isn't coloured in, it's an open line, or an open dot, sorry. So you don't put the equal to in. So this diagram shows that x is less than 2, not less than or equal to 2. If it was less than or equal, that dot would be coloured in. Then part C is linking up part A with part B. So write down all the integers that satisfy both inequalities shown in parts A and B. So part A, it said that x was bigger than or equal to -1. So there's -1 there, and it's saying that it's allowed to be equal to -1, so that would be like changing the picture like that. So x is bigger than or equal to -1, and then you can't go beyond 2. So write down all the numbers here that appear on the number line between those two dots. So that would be -1, 0, 1 and 2. But then you need to look at the fact that it said that it was allowed to be equal to -1. That's why I coloured in that dot. But up here it says that it's not allowed to be equal to 2. So therefore you can't have 2 as one of your answers. It has to stop before them. And integers are just your whole number, so they mean they don't want you to put in like every single decimal place or fraction that it could be between those two, just the whole numbers that are actually on the number line. Question 21, I've just got some more practice with these number lines. So circle the diagram that represents 1 is less than or equal to n, which is less than 3. So they mean that n is between 1 and 3, but that doesn't really help much because all of the pictures go between 1 and 3. The only difference in the pictures is how the dots are, whether they're coloured in or left empty. So a less than or equal to, because it's allowed to be equal to, that should be a coloured in dot. And then at the 3, because it doesn't have an equal to sign underneath it, it should just be an open dot, an empty dot. So that would be this one, the last one. So you're looking for a coloured in dot at 1 and an empty dot at 3. So coloured in dot at 1, empty dot at 3. So the last picture or the last diagram represents that inequality. Number 22. Again, a wee bit more work just on these inequalities. So n is an integer, so that means that it's a whole number. List the values of n such that -6 is less than or equal to 3n, which is less than 13. So, at the minute, this inequality isn't actually to do with n, it's to do with 3n. So the first thing that you would need to do is to change it from 3n down to just n. So you would do that by dividing everything, each wee bit, by 3. So 6 or -6 divided by 3 gets you -2. The 3n divided by 3 gets you n. 13 divided by 3, you can either get it as a decimal or do 3 goes into 13 4 times. 3 4s would get you 12, and then there's 1 left over, so the 1 would go over the 3. So 13 divided by 3 is 4 1/3, or if you allowed your calculator it would be 4 point and then a whole load of 3's. So now we've got n here. This means that n is all of the numbers between -2, sorry I was going to say -4, -2 right the way up to 4 1/3. So that would be -2, -1, 0, 1, 2, 3, 4. And then you need to look at the arrows to see whether you're actually allowed all of those numbers or if you need to get rid of some of them. So it says that it is allowed to be equal to -2, so that's okay, we can keep that. This one said less than 4 1/3, but we didn't even go up as far as 4 1/3 anyway. We stopped at 4 because we were looking for the integers, so it's okay to keep the 4 there because we didn't go up as far as 4 1/3. So that's what it means by list the values of n. You would just list all the numbers that would appear on a number line if you were to draw it like one of these ones here. All of the numbers that would be allowed on the number line. Number 23, list all the solutions of the inequality where n is an integer. So this is the same kind of idea. N is a whole number and they want all the solutions for n. So this is 2n, so you need to go along and make it all into just n by dividing everything by 2. So 4 divided by 2 gets you 2, 2n divided by 2 gets you n, 11 divided by 2 gets you 5.5 or 5.5, whatever way you want to write it. So this would be all of the numbers, 2, 3, 4, 5. So all of the numbers on your number line between 2 and then 5.5. Because you're only looking at integers, then you wouldn't go up to 6, you would just stop at 5. But according to the arrows, this arrow here doesn't have an equal to underneath it. So that means that you can't include the 2, so you wouldn't have that as your final answer. And it says less than or equal to 5.5, but again, it doesn't really matter up here because we didn't go up as far as 5.5. So your final answer would just be 3, 4 and 5. Right, the next bit of algebra that we're looking at then are patterns, sequences and nth term. So it starts off easy enough where it's just to do with patterns, like simple number patterns. So write down the next two terms in the following sequence, 3, 6, 9, 12. So you're just going up in your 3 times tables there, you're just going up by 3 each time. So 3, 6, 9, 12, so the next one would be 15 and the next one after that would be 18. So the term to term rule there is just that you're going up in 3s. Number 25, write down the term to term rule for the following sequences. So they're wanting you to say, is it plus 2, is it times 5, what's actually going on here. So from 21 down to 17, they're getting smaller by 4, going down by 4 each time. So your term to term rule is just take away 4. The next set of numbers are getting bigger, but not by the same amount each time, so that means that it must be timesing. So 2 times 2 gets you 4, times 2 gets you 8, times 2 gets you 16, times 2 gets you 32. So times by 2 would be the term to term rule. So each of these numbers here are just a term, so they want to know how you get from this one to this one to this one to this one to this one. Number 26 is a bit different. It says work out the nth term rule for the following sequence. So it's not just, oh look, they're going up in 4s. The nth term is to do with this one being labelled the first term, this is the second term, this is the third term, and this is the fourth term. And what they're wanting you to do here is find a connection between the 1, 2, 3, 4 and the 3, 7, 11, 15 that works to bring you from the 1 to the 3, the 2 to the 7, the 3 to the 11 and the 4 to the 15. And it's always going to be times by something and then add or subtract something. So if you're quite good with numbers and patterns and things like that, you could just sit and try to work it out on your own and try to think, do a times by 4, do a times by 5, do a times... Or another way that you can do it, if you look at the term to term rule here and look to see what these are going up in, so they're going up in 4s, that gives you a clue that the number that you're timesing by is 4. So times 4, times 4, times 4, times 4. After that then, the reason why it's called the nth term is that it has to work for any of these terms. So pick any of them, even the last one there, 4 times 4 is 16. And then to get back to 15, you would have to take away 1. So check that it works for a few more of them. 3 times 4 is 12, take away 1, yes that's 11. 2 4s are 8, take away 1, yes that's 7. 1 times 4 is 4, take away 1, yes that's 3. So you find the pattern. You're taking any of the terms, the nth term, and timesing it by 4 and then taking away 1. And then you just need to write it properly in algebra, because n times 4 you would write as 4n and then take away 1. So that means pick any term, times it by 4, take away 1, and you will get the corresponding number in the sequence. So if you wanted the 50th term, you would do 50 times 4, take away 1, and that would tell you what the 50th number in the sequence is. So part B, the same kind of thing. Label them first, second, third, fourth. Look to see what you're going up in. This time you're going up in 3s, so that means times by 3. Pick any of them. So I'm just going to pick the last one there, the fourth one. So 4 times 3 is 12, and then plus 2 gets you 14. 3 3s are 9, yep, plus 2 gets you 11, it's working. 2 3s are 6, plus 2 gets you 8. 1 times 4 is 4. Why is that not working? That would be plus 1. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is that not working? Oh, just realised what I did. I wrote it times by 4 and all the other ones was times by 3. So 1 times 3, and I've just written down times twice. See, that's why it's important to actually check it works for all of them. So 1 times 3 is 3, and then plus the 2 gets you 5. So you're picking any of the terms, times them by 3 and plussing on 2. And then just write that out properly. So n times 3 gets you 3n, and then plus the 2. So if you pick any term, times it by 3 and plus 2, you'd get the corresponding number in the sequence. Number 27, find the first 4 terms of the sequence whose nth term is 5n minus 3. So they're wanting you to actually work out the sequence. So the first 4 terms, you would have 1, 2, 3, 4. And this means times 5 take away 3. So take the first term, times it by 5 and take away 3. 1 times 5 is 5, take away 3 would get you 2 is the first number in the sequence. And then go to the 2, times it by 5 and take 3. 2 times 5 is 10, take 3 gets you 7. Then go to the 3, times it by 5 gets you 15, take away 3 gets you 12. Then the fourth term, times it by 5 gets you 20, take away 3 gets you 17. Another way that you could do this is if you just get the first term, that 5 there in front of the n means that they're going up in 5, so you could go on and get the other ones after that. But I would just stick to writing out the whole method to make sure that you get all the marks in the exams. So the last bit that I want to look at in algebra then is changing the subject or rearranging the formula. So these are questions that say things like rearrange the formula to make x the subject. So this one, make y the subject of the formula. At the minute, x is the subject of the formula. That just means that x is what the formula is all about. And they want you to rearrange it so that the formula is all about y. So that means so that y is on its own. So it's a wee bit like solving equations, but you don't actually get an answer. So for you to get y on its own, you just need to get rid of that times by 3. So bring it to the far side and it turns into a divide by 3. So you would have x divided by 3 equals y. And that's it. You've rearranged the formula, you've made y the subject, you've got y on its own. In the exam they normally have y first. So y equals and then x over 3. They normally have it like answer y equals and then you just fill in the x over 3. Number 29, the same sort of idea. This time we want to make d the subject of the formula. So at the minute a is the subject, so we want to rearrange it to get d on its own. So if we were going to solve that equation, you would get rid of the minus 7 first of all and bring it over there and plus 7. So you would have a plus 7 equals 5d. Then you would get rid of the 5 by bringing it over there and dividing by 5. So to show that you're doing all of this side dividing by 5, you would just use a massive fraction. So you would have a plus 7 divided by 5 equals d. And again, in the exam, they might want you to put the d on the first side and then that on the second side. Number 30, the last question. Make x the subject of this formula. So this time we've got no numbers here at all, so we're just rearranging a whole load of letters and we want to make x the subject. So to get x on its own, leave it with the m for a wee minute and get rid of the plus c, bring it over to that side and take away c. So you've got y take away c on the first side equals mx, and m times x. To get rid of the times by m, then bring it over there and divide by m. And then this will look a wee bit like the last question. You'll just have a massive fraction with y minus c on the top, m on the bottom, and then x on its own. So you've rearranged the formula, you've got x on its own, you've made x the subject. Okay, that's the end of algebra.